Okay, so the second lesson in Unit 4 is over point slope form. So this is 4B. So these first three problems up here are just kind of a review and recap of 4A, just because you are going to want to know 4A pretty well before you do point slope form. So for these first three problems, you are just wanting to write the equations in slope-intercept form. So as mentioned before, slope-intercept form is just y equals mx plus b. So we have our slope, and we have our b value written here, since it's 0, a number. So equation here is just going to be y equals 2x minus 5. So that's your first equation. So now over here. So emphasis on the title of the lesson, point slope. So we actually have a point and we have a slope. So we're actually going to be using point slope form to rewrite these equations in a different way. But that'll be for later. So really think about the names of the equations. Slope, intercept form. It has a slope, it has an intercept. Point slope form. It has a point and it has a slope. So in this way, or in this problem, we're still going to write it in slope intercept form. So I'm going to start with y equals mx plus b. So I'm going to plug in the point and the slope. So I'm going to have 11 equals -4 parentheses -2 plus b. So I'm going to have 11 equals 8 plus b. When you multiply -4 and -2, now I want to move over that 8. So I'm going to subtract it on both sides. So 11 minus 8, let's see if I can do math, gives you 3. So our b value is 3. So now for your equation, so we're going to have y equals -4x plus 3. So that would be our equation. All right, now same idea over here, except now I give you 2 points. So you have to find the slope first. So I'm going to do y2 minus y1 over x2 minus x1. That's not right. There we go. Okay, so now y2 minus y1. So I'm going to have -2 minus 6 over 6 minus -2. So I'm going to have -8 over 6 minus -2, which turns into 6 plus 2, which is going to be +8. So I'm going to have a slope of -1. So now I want to start in slope-intercept form, and I want to solve for the b value. So y equals mx plus b. So it doesn't matter which point you use. It really doesn't. So I'm just going to choose a random one. I'll just choose the very first one. So -2, 6. So now I'm going to plug in 6 equals slope of -1, x value of -2 plus b. So now I'm going to solve. So 6 equals -1 times -2, which gives you +2 plus b. So now I'm going to subtract 2 on both sides. So you're going to get a b value of 4. So now your equation, we're going to have y equals -1x plus 4. So you don't have to write that 1. So your equation here is just going to be y equals -x plus 4. All right, so now we're going to really take a look at point slope form. So point slope form here is y minus y1 equals m times x minus x1. So x1, y1 represents the coordinate that we're going to be plugging in, or the point, and then your m represents the slope. So as mentioned before, really think about what the name is telling you. In point slope form, we have a point and we have a slope. Slope intercept, we have a slope and a y-intercept. So now I'm going to start writing these equations in point slope form. So I'm going to be given a point and a slope, and I'm going to be subbing in for 3 of those values. So x1, y1, and the slope. You leave x and y alone. Do not plug anything in for x and y. So you do not touch either of those values. All right, so what we're going to be doing now is I'm going to take my slope and my point. So my point is x1 and y1. So now I'm going to have y minus y1. So y minus negative 5 equals my slope, which is 2, parentheses x minus my x value, which is 0. So when you get to this point, typically you may be done, or you may have to simplify. So when I say simplify, what you're going to have to fix is any subtract a negative. So when you subtract a negative, that turns into plus a positive. So y plus 5 equals 2 times x minus 0. So this equation right here, this is your point slope form. So that's what we're looking for. All right, so now over here, same idea. So I have my x1, y1, then I have my slope. So I'm going to plug everything in. So y minus 11 equals my slope, which is negative 4, then x minus a negative 2. So I'm going to write that in parentheses and then close it with a double parenthesis. So now I have to simplify x minus negative 2. So that's going to turn into y minus 11 equals negative 4, parentheses, x plus 2. So now this is our final answer. All right, so a lot of these problems may just be a case of here's the point, here's the slope, plug it in, simplify. Or I may actually give you 2 points and you have to find point slope form. So the first thing you're going to have to do is find the slope. So still x1, y1, x2, y2. So this is just in terms of finding the slope. So I'm going to have negative 2 minus 6 and 6 minus negative 2. So this is going to give you negative 8 over positive 8, which equals negative 1. All right, so now here's the thing. We have 2 different points here on this problem. So which one do we use for point slope form? Well, the answer is it doesn't matter. You can use either one of those points. You have options. So I'm actually going to show both, but you only have to provide one. All right, so let's say for option 1, I use negative 2 comma 6. So I'm going to have y minus y1 equals m times x minus x1. So I'm going to plug in my slope for negative 1, and then these are the points that I plug in for x1, y1. All right, so I will have y minus 6 equals negative 1, parentheses, x minus negative 2. So there's 2 things in this problem right here specifically that we can simplify. So the first one is that negative 1. We don't have to write that 1. So I just have y minus 6 equals negative, parentheses, and then the second thing that we can simplify here is minus a negative. So plus 2. So this would be our first option. Now our second option down here, same idea. So y minus y1 equals m times x minus x1. All right, so I'm going to have my x1, y1 over here that I'm going to pull again. So I'm going to have y minus negative 2 equals slope of negative 1 times x minus 6. So we're going to have y plus 2 equals negative parentheses x minus 6. So this is what we're going to have. So here's the thing. Either one of these on an assessment or a practice or whatever will be accepted. On the practice, you would only have to write one equation. You don't have to provide both. All right. So one thing to actually note that I forgot to mention, these equations are actually the exact same. So I'm actually going to show you guys later on in this lesson how those are the same. All right, so same idea here. So I would actually say pause here and actually try this one on your own. It's very similar to number 3. Or you can just watch, it's up to you. So x1, y1, x2, y2. So start by finding the slope. So y2 minus y1 over x2 minus x1. So 7 minus negative 11 over 2 minus negative 1. So 7 minus a negative 11 turns into 7 plus 11, which gives you 18. Then 2 minus a negative 1 turns into positive 3, which when you simplify gives you 6. All right, so same idea down here. I have two different options. I can use either one of those points. It doesn't matter. So I'm going to start with y minus y1 equals m times x minus x1 for both. So I'm actually going to copy and paste this down here. All right, so I know my slope is positive 6, so I'm going to plug it in. So y minus negative 11 equals positive 6, parentheses, x minus negative 1. All right, so now we got to simplify. So y plus 11 equals 6, parentheses, x plus 1. So there is our first equation. All right, and then for a second option, we're using the other coordinate. So remember, it doesn't matter which one you use. You can use either one. I'm just doing both so that you can see whichever one you used if you got it right. All right, so now y minus 7 equals 6, parentheses, x minus 2. So if you notice on this one, we don't have to simplify anything, so we're done on that one. So my advice is really look for the coordinates that are, if possible, both positive, regardless of what the number is. If they're both positive, that means you have no more simplifying that you have to do. So one thing to notice, look at your coordinates and look at the equation. I have a negative 1, but I'm adding 1. I have a negative 11, but I'm adding 11. I have a negative 7, but it's a positive 7. Negative 2, but it's positive. The signs and what they are in the equation are complete opposites. So please be aware of that. All right. Also be sure you're plugging into the right place because the y does come first and a lot of people want to plug in the x value first. So just be wary. All right, so for number 5 here, so we'll start with y minus y1 and times x minus x1. So start with point slope form. So I'm just going to plug in exactly what the values tell me. So x1, y1. All right, so I'm going to have y minus 6 equals my m value, which is negative 3/4. Then x minus negative 4. So I need to simplify that minus a negative. So I have y minus 6 equals negative 3/4 x plus 4. So here's our equation. All right. Number 6. So I need to start by turning these into coordinates. So this is going to be 2, 3. And this over here will be 4, 4. All right, so I need to find the slope first. So x1, y1, x2, y2. So y2 minus y1, x2, nope, there we go, minus x1. All right, so y2 minus y1, so I'm going to have 4 minus 3 over x2 minus x1, which is 4 minus 2. So 4 minus 3 gives you 1 over 4 minus 2, which gives you 2. So we have a slope of 1/2. All right, so option 1. Let's use 2, 3. And then for option 2, we'll plug in 4, 4. Alrighty. So I'm going to start with y minus y1 equals m times x minus x1. All right, so we have a slope of 1/2. So I'm going to have y minus 3 equals 1/2 x minus 2. All right. So there's that equation. So we're not subtracting a negative, so we don't have to simplify anything at all. All right, now for option 2 over here, So y minus y1 equals m times x minus x1. So I'm going to have y minus 4 equals 1/2 x minus 4. So once again, not subtracting a negative, so there's no simplifying. All right, so there's the first 6. So really these are just writing it in point slope given whatever we have. All right, so now for this next section, we actually want to write the equations in both slope-intercept form and point slope form. So we're going to be doing some converting. So some good advice, always start with point slope form and then convert it. So I'll show you why this is actually a lot better. Because if you notice here, we're actually given a point and a slope. So here, that should tell you it's better to start in point slope form. So I'm going to start with y minus y1 equals m times x minus x1. All right, so I know my point here is x1, y1. So I'm going to do y minus 2 equals 6 parentheses x minus 0. So here is my point slope form. So that part is done, but now I need to convert and actually put it in slope intercept form. So what I'm going to do is I'm going to continue to simplify. So I'm actually going to rewrite it as y minus 2 equals 6 parentheses x. X minus 0 is just x. So I'm going to have y minus 2 equals 6x. Then I'm going to add 2 on both sides. So I have y equals 6x plus 2. So we have both the point slope form and now we have slope intercept form. So really the big idea here with point slope form is really helpful when we're converting equations. All right, so I'm going to do the same idea over here. So start with point slope. So y minus y1 equals m times x minus x1. After you write the equation 20,000 times, I can almost guarantee you're going to remember it. All right, so here's my x1 and y1. All right, so y minus positive 1 equals slope of negative 1 parentheses x minus negative 1. All right, so we have a couple things that we can simplify here. So y minus 1 equals negative parentheses x plus 1. So this is our point slope form, but now we're going to convert this into slope intercept form. So to do that, I'm going to start by distributing this negative. So y minus 1 equals negative x minus 1. So next, I'm going to add 1 on both sides so I can get y by itself. So we're going to have y equals negative x plus 0. They just zero out, which means our equation here is just y equals negative x. So here is our slope intercept form. So it's really close to the linear parent function almost. All right, so really these problems down here just focus a lot on converting. All right, so number 3. All right, so now they kind of add an extra step here. So you have to find the slope. So x1, y1, and x2, y2. So y2 minus y1, x2 minus x1. So I'm going to have 0 minus 5 over 4 minus negative 6. So we're going to have negative 5 over a positive 10, which simplifies to negative 1/2. All right, so now we want to write it in point slope form. So it doesn't matter which point you use, really it's up to you. So I'm actually going to do this in 2 columns, which you don't have to do the 2 columns. I'm just showing you that it doesn't matter which one you choose. All right, so option 1, which I will use negative 6 comma 5. And then option 2, which I will use 4 comma 0. Okay, so I'm going to start with y minus y1 equals m times x minus x1. All right, so I'm going to plug in my point and my slope. So y minus 5 equals negative 1/2 x minus negative 6. So I'm going to simplify before I start converting. So y minus 5 equals negative 1/2 x plus 6. So here's my point slope form. All right, so now I'm going to start converting. So I'm going to distribute that 1/2. So I have y minus 5 equals negative 1/2 x. Now, negative 1/2 times a positive 6, you're just dividing 6 by 2, and it's negative, so you get negative 3. Now I'm going to add over 5. So I'm going to have y equals negative 1/2 x plus 2. So here's my slope-intercept form equation. So there's option 1. So as mentioned before, it doesn't matter what point you use. So y minus y1 and x minus x1. All right. So plug in the point. So y minus 0 equals negative 1/2 x minus 4. Now, if you look here, y minus 0, well, that's just y equals. So we're off to a great start. And then I'm going to distribute this 1/2. So I'm going to have y equals negative 1/2 x plus 2. So if you look, it's the same exact equation. So it doesn't matter which one you use. Either way, you're going to get the same slope-intercept form. So there's your point slope form. So as mentioned before, you only have to do one of these. You do not have to do both. This is more just to show you, no matter which one you use, you should be getting the same thing. Okay. All right, so from here on out, I'm only going to just do 1 point. I'm not going to do both. All right, so for number 4, start by finding the slope. Hello, there we go. So m equals y2 minus y1, x2 minus x1. So I'm going to have 20 minus negative 10 over 8 minus negative 4. All right, so 20 minus a negative 10 turns into 20 plus 10, which is 30. And then 8 minus negative 4 turns into 8 plus 4, which gives you 12. So this will simplify. If you divide both of those values by 6, you get 5/2. All right, so I'm actually going to use, for my point, I'm going to use negative 4, negative 10. Just because the numbers are smaller. I'd rather deal with negatives than deal with bigger numbers. But that's just me personally. So y minus y1 equals m times x minus x1. So minus the negatives and to turn into plus a positive. So we're going to have y minus negative 10 equals 5/2 x minus, is it negative 4? So now I'm going to simplify. So y plus 10 equals 5/2 x plus 4. So here's my point slope form equation. So now I want to convert this to slope intercept form. So I'm going to distribute. So I have y plus 10 equals 5/2 x plus, now 5/2 times 4 gives you 10. So you could do 5 times 4, which gives you 20, 20 divided by 2, which gives you 10. Or you could do 4 divided by 2, which is 2, 2 times 5, which is 10. Either way, it works. All right, so now I'm going to subtract 10 on both sides. So I can get y by itself. So I have y equals 5 halves x. The 10s here, they just zero out. So this is my slope-intercept form equation. All right. So my advice here, I would say pause here, try 5 and 6 on your own. Or don't. Everything's fine. Okay. Y minus y1 equals m times x minus x1. So one question I get asked a lot is, how do I remember all these formulas? Well, continuously writing them over and over like this helps a lot. I'm just saying. All right, so now I'm going to do y minus y1. So y minus 4 equals my slope, which is negative 4/3, x minus x1, which is 6. So here's my point slope form. Now I need to convert. So I'm going to distribute. So I have y minus 4 equals negative 4/3 x. Now we're going to have positive. So 4 times 6 gives you 24, divided by 3 gives you 8. Or 6 divided by 3, which gives you 2, 2 times 4, which gives you 8. All right, now I'm going to get y by itself. So I'm going to add 4. So I have y equals negative 4/3 x plus 12. So there's my slope-intercept form. All right. And so we have our function notation. So I'm going to turn these into coordinates. So we have negative 1, comma, negative 15. And then we have 4, comma, 10. All right, so what I'm going to do here, so I'm going to do my slope formula. All right, so y2 minus y1. So 10 minus negative 15 over 4 minus negative 1. All right, so 10 minus a negative 15 turns into 10 plus 15, which gives you positive 25. And then 4 minus negative 1, which turns into 4 plus 1, which gives you 5. Simplify, and you have a slope of 5. All right, so I'll do 4, comma 10. I'm very indecisive. I will sit here and stare at the screen for like 10 minutes before I figure out which one I want to use. All right, so I'm going to use 4, comma 10. So y minus y1 equals m times x minus x1. So y minus 10 equals slope of 5 and x minus my x value, which is 4. So there's nothing else I can simplify here. So this is my point slope form. So now I'm going to distribute. Oh my gosh, why is that one darker? Everything's not fine. All right, so y minus 10 equals 5x minus 20. So I'm going to add 10 on both sides. So y equals 5x minus 10. All right, so really a big takeaway of today is knowing that point slope form is used as a middleman when converting. It's very important. Okay, so we can also graph using point slope form. So whenever we're graphing, you always want to take the point first. So take the point and you want to take the opposite signs from the coordinates. So my point is x1, y1. So remember, this is our x1, this is our y1, and I want to take the opposite of what those actually are. So even though it's minus 5, that's a positive 5, and even though it's minus 3, it is positive 3. So what I'm going to do is start with the point. So just like when graphing slope-intercept form, you have to start with the y-intercept. With point-slope form, now you have to start with the point. You're still starting with a starting point. All right, so here is 5, 3. And then from that point, then I'm going to apply the slope. So I have a slope of 2, which means I'm going to go up 2 and right 1. So I'm going to go up 2, so 1, 2, and right 1. All right, so those are the only 2 points you actually need to graph. So I'm going to use that to my advantage. So I'm going to use the scissor tool, draw and extend. Perfect. All right. So now over here for the second one. So I know my coordinate is going to be 4, -1. So the opposite of both of those. So a -4 means I'm taking a +4. And then the +1 means I'm taking a negative. So I'm taking the opposite of what those are. All right, and then I'm going to do a slope of -1/2. So at 4, -1, put a point. And I want to go down 1, right 2. So I just need one other point. And I can draw my line. All right. So now for this equation, once again, taking the opposite. So my coordinate here, if I have a +5, that means my x value is -5. And if I have a -8, it means my y value is a +8. So I'm going to start at -5, 8. So here's my starting point. And now if you notice, there's no number right here in the very front. So we assume that it's a -1. So I'm going to go down 1 and right 1. So down 1, right 1. So there's my other point. Oh, no. There we go. All right, so there's the graphs. So the important part here, so the takeaway here, start with the point, then apply the slope. Just with the point, remember you're taking the opposite signs. All right, now we have some word problems. Everyone's favorite. All right, so with point slope form, we're really looking for a point and a slope. So we're looking for an x1 and a y1, and we're looking for some sort of rate. So a local band was reserved for a party. They charged $50 per hour for their performance, plus a surcharge for transportation, setup, and other fees. So the band was reserved for 5 hours, and the total cost for reserving the band is $335. So notice here how they say that they are charging $50 per hour. That's your rate. So this is your slope because it says per. That's a rate. Now, if you look here, they are reserved for 5 hours, and the total is $335. So they reserved for 5 hours, that's your x1, and then the 335, that's your y1. So we can write our equation in point slope form. So we have y minus y1 equals m times x minus x1. So y minus the total cost, 335, equals our slope, which was 50, x minus 5. All right, so now we want to find what does the slope represent. So the slope in this case is going to be the $50 per hour. So the charge per hour for the performance. charge per hour All right. So now we want to write an equation in slope-intercept form that represents the same scenario. So I'm going to take my equation from A, I'm going to copy it down here, and I'm just going to convert it to slope-intercept form, which means I'm going to solve for y. So I'm going to distribute. So I have y minus 335 equals 50x minus 250. So now I want to be able to solve. So first thing I'm going to do is I'm going to add 335 to both sides. See if I can do math. What is that? 85? Yes. So y equals 50x plus 85. So that's our equation in slope-intercept form. And now they want to find the value of the surcharge. So the surcharge here is, remember they were saying $50 per hour plus a surcharge. So the surcharge is just the B value. So our surcharge here is 85. So keep in mind, these are what we call domino problems. So if you mess up part A and you get the wrong equation for point slope form, then the rest of it's going to kind of fall flat. Like if you don't have the right equation for part A, you're going to convert the wrong equation and then you're going to have the wrong surcharge. So be very careful with part A. All right, same idea here. So Anne is a waitress at Chili's and she earns an hourly pay plus whatever she earns in tips. So she earns $9.50 per hour as a base pay. So $9.50 per hour as a base pay. So this is your slope. And after she works 40 hours, she earns a total of 565. So after 4 hours, so that's your X1, she earns a total of 565, which is your Y1. All right, so now they want point slope form. So Y minus Y1 equals M times X minus X1. So Y minus 565 equals the hourly rate of 950 and X minus 40. So there's our point slope form. And now we want to find out, what does the slope necessarily represent? So this is the hourly base pay. So if she gets no tips, then she has $9.50 an hour. All right, so now we want to write an equation in slope-intercept form that represents the scenario. All right, so I'm going to take my equation from part A. I'm not even going to try to do this mentally. Where's my calculator? All right, so first thing is to distribute. All right, so y minus 565 equals 950x, then 950 times 40, which gives you minus 380. All right, and now I'm going to add over the 565. All right, and then she's gonna have y equals 950x plus 185. All right, so that's our equation in slope-intercept form. And now they want to know what's the value of the amount of tips, which is the hourly base rate plus our charge here. So this equation is saying that she earned $185 in tips.